Hello, and welcome back to the H-Span podcast, your go-to podcast for longevity policy discussions. I'm your host, Dylan Livingston. In this episode, I sat down with Dr. Nir Barzilai, the founding director of aging research at the Albert Einstein College of Medicine in New York. As one of the pioneers of longevity research, I wanted to get an understanding of how he got into longevity science, as well as his thoughts on the current state and future state of the field as it pertains to the science and the regulatory process. Without further ado, here's my discussion with Dr. Nir Barzilai.
Live long and prosper.
All right. Thank you, everybody, for joining us again for another installation of A4LI's H-Span Policy Podcast. We are joined today by Dr. Nir Barzilai. Nir, would you like to introduce yourself to our audience really briefly before we get started?
Sure, but I want first to reintroduce you, Dylan, because first of all, you're young, so I'm already jealous. And you're very active, and you have a really great purpose in life that also joins my purpose. So thank you for doing what you're doing. I need you, and I need people like you. You know the concept of chronobiosis. You take a young animal and an old animal, and you tie them together, and they share their blood supply, and the old animal becomes younger. So I like our chronobiosis. It's good. It's good for the field, and it's good for everyone else. Thank you.
You know, you're scaring me a little here. Does this mean we're gonna like hook up our circulatory systems or something like that? Because
only by Zoom.
Oh, that's funny. Well, thank you, Nir, for that. I appreciate that. Yes. So before we get started, though, could you give our audience a little bit about, where you are, what you do, your positions and your pedigree and all that. I gave a brief intro in our, in our intro here, but if you want to go into more detail, that'd be great.
Well, I'm running one of the biggest center in the world for the biology of aging out of Albert Einstein College of Medicine. But I'm also the scientific director of the American Federation of Aging Research, and I'm also in the executive committee of the Longevity Biotech Association, and I'm also one of the founder of the Healthy Longevity Medicine Society. And I'm saying all that because when you have all those affiliation, it shows mainly how old you are, but more important, it shows you where the field is, because I started as a biology, and we thought that, maybe the biology has hope. And now that we show that the biology has promise, we're all in how do we capture the promise? And
Sure.
That's why I'm involved from everything from the research to the biotech to actually the clinical thing, because listen, aging can be targeted, it can be delayed, it can be stopped, it can be reversed in several situations, and we have to bring it to our public.
Well, to add one more to that list, Nir, you're also on the scientific advisory board of A4LI. So, you add advocacy to that because you're, obviously very, very involved with, all, like you said, all aspects of this field.
Absolutely. I didn't mean to forget it. It's just what I'm doing now, right? So
no, I know. I just wanted to. That was more bragging for our A4LI audience. Yeah, guys, we have Nir Barzilai on our scientific advisory board. I'll brag about that. But so that's great, Nir. So I like to start off these podcast talks by getting into our guests' background, right? So what was your kind of aha moment? What was the moment that made you realize you wanted to go into aging and make such a large impact on the world? Who are your inspirations, and when did you come to that realization?
Well, we have only 45 minutes, so let me give just two examples that I thought were crucial here. One that happened when I was pretty much 13 years old. And it has to do with my grandfather and listening to my grandfather stories about his youth. And the point is that we say that children have imagination, but I think, Dylan, when you looked, maybe not now, but when you looked at your grandparents, you didn't say to yourself, oh, that's how I'm going to look when I'm their age. It was more like, I have no idea how they got here. You know, they look, what happened to them, right? And somehow this became eventually an obsession. I mean, how could he do all those things? And now he was, by the way, he was only 67 or 68 years old, but he looked old, he was heavy, he was slow, he was bald. How is it the same man?
Mm-hmm.
And I thought this biology is really the biggest biology there is. This is just fascinating, just amazing.
Mm-hmm.
You see it always cross-sectional. You don't think of, just a minute, this is an evolution. I'm going to get there. The second thing is when I was a resident, actually, in internal medicine. And I realized that you could take a whole audience of people between 50 and 80, okay, in a lecture hall. And if I ask you, okay, who has diabetes, you wouldn't be able to predict, or who has hypertension, and you wouldn't be able to predict, or who has high cholesterol level, right? Mm-hmm. But if I ask you who's closer to 50 and to 80, you would know. Okay, it was always for me like, oh, we're talking about cholesterol, but there's something else going on, Right. He's old. Right. Okay. And I think those are the things that made me think that aging is really the major biology that we have to tackle. Sure. And that became my purpose.
Sure. Yeah. Well, when you're young, you don't really think about aging, right? And even people, I'm about to turn 25 in a few months. Like, even people my age, right? It's hard to get them kind of understanding that this is in the cards for them, right? And so I don't think it's just like a young child thing. Yeah, I mean, I still think people, but once you're awake to it, and I think you'll probably agree to this, once you're awake to it, it's hard to really go back. Like once you're kind of awake to the fact that aging exists, and not only it exists, it's something that can be targeted against, right, and fought against, right? So I share that. Mine came maybe a little later in life than you. I was probably like 21 when I had my realization about aging, right? But it happens, I feel like, for everybody in this space, and so that's fascinating.
But the advantage, and I agree, but the advantage of your generation is that you already know, if you're curious, you already know that you can do something about it. Right. So that's where it's like, because my mother, my grandparents, there's nothing you could do about aging, right? That was how everybody looked at it. And my response now is, maybe you cannot do anything about death, but aging, yeah, you can do Absolutely. Something about aging. And now that it's out there, younger people are saying, well, maybe we have to start it now.
Yeah. Yeah. Well, we're standing on the shoulders of giants, Nir, and you're one of those giants. So,
I'm 7'5". No, I'm 5'7".
You're a giant, standing on the shoulder of giants. You're one of them. It's true, right? I mean, my generation wouldn't know about this if it wasn't for you and the previous generation, right? And so hopefully the generation that's just born will grow up in a truly a society where aging is thought to be malleable and something that should and could be targeted against, right? So
amen.
As we keep going and humans evolve, we'll get to that point, right? So that's great. So we talked a little bit about what you're up to in the intro. Would you be willing to maybe go into more depth, specifically, I would say, and most people would say you're one of the most famous things you've done in the field is the TAME trial. Would you like to maybe give our audience an update on how that's going, where the timeline is, maybe talk about, the grant that you guys got from the Evolution Foundation. Maybe you can talk about some of the bigger things that have happened in your orbit over the last few years.
There are three things that came in part out of my lab and have been successful, and therefore I'm pushing them in a national, international level. And by the way, a lot of it is through the American Federation of Aging Research. We have 3 initiatives that I want to highlight. The first initiative is called the Super Ager Initiative. And this is based on the fact that one of my studies was centenarians and their families. And the hypothesis was that centenarians have longevity genes that slows their aging. Mm-hmm. And we showed that we have specific genes, and 2 of our findings have even been translated to medicine, although not for longevity, but for some age-associated disorder. So there's a real proof of principle. And the last proof of principle, by the way, was when we looked at genetic and we were doing whole exome sequencing to the whole population. We find that what distinct the people with longevity versus the people who don't have longevity in the family is the same things that we learned from animals. It was the insulin growth hormone signaling pathway and mTOR signaling pathway and lots of buzzword that we accept as the holy grail in geroscience. So the initiative is actually to register, the people who are in a Parkinson association register Parkinson people, and those that are type 1 diabetes, they register type 1 diabetes. What will a FAR register? Not every old person in the United States, but in fact, we want to register the families of centenarians. So we are going to approach 10,000 centenarians and basically ask them to give saliva and have genetic information and find all the longevity genes that can slow aging, and share it with the academic community and really understand the exceptional longevity in humans. Okay, we die before the age of 80. They lived not only longer, but they live healthier until the end of their lives. Right. And not only they live healthier till the end of their life, they had a contraction of morbidity. They were sick very little time at the end of their life. So there's a lot of so it's an example of people we want to imitate. We want to be healthy, and die. Right. And so that's one initiative. The second initiative is called FAST, and I don't remember what FAST stands for, but the word FAST is we want to do it fast. And the idea is it's a biomarker proposal. And the idea is that there has been studies in the last years or even decades that have used gerotherapeutics, like metformin, like SGLT2, like lifestyle intervention in clinical trials that had outcomes of decrease in several age-related disease and mortality, and to go into their resources and take blood, plasma, other stuff, and actually use high throughput methods, what we call omics, to find what are the biomarkers of those gerotherapeutics. What changes within a year of therapy that will predict the outcome? What are those drugs doing that are related to aging? And if we can identify those things, then, now I'll get to the TAME, but the TAME is like a phase 3 trial. It'll take 5 years. Well, if every invention of us is going to have a phase 3 trials, it'll take much longer, and a lot of them will fail. So we need to have some measure of the success in the biomarkers. By the way, we hear about biomarkers and about clocks that distinct between our biological and chronological age. Okay, we might be younger biologically than our chronological age, or older. But we're talking about biomarkers that will change with treatment. Not all the clocks will change with treatment. We have to find those that are changing with treatments. So this is the FAST initiative. And the last initiative is TAME, which stands for Targeting Aging with Metformin. And really, we're taking a drug that have shown to be gerotherapeutics. It works in animals, it works in cells, it works in and in humans, it prevents mortality and age-related disease and everything else. Okay, so we know that already, but we went to the FDA, and when I say we, are the leaders, the scientific leaders of the field. We went to the FDA and met with a lot of the head of their departments, and we said, look, we want to repurpose a drug that's called metformin, that is generic and cheap, by the way, and by the way, it's the cheapest drug in the U.S. pharmacy, I think. It still is, and repurpose it to target not one or two or three, but many age-related disease. We don't know what disease you're going to have, but you're aging, so you're going to get your next disease, and for every disease you get, you're getting a point. Mm-hmm. But in the people versus placebo, in the metformin versus placebo, we're going to push you. Okay, we're going to delay or prevent those diseases. This is the trial. And I put it this way because this is really a need for the FDA to know that we target aging, and that there's a template for all the other drugs that are coming, for all the pharmaceuticals that are going to develop better drugs and combination of drugs, so that there's a way forward, so that healthcare providers will be able to pick the drugs and pay the customers. That's what we're trying to do, really. And this first success is going to open a door to a lot of things, including to the lobbying, okay? Because in the lobbying, they can say, okay, you treat animals, you cured mice and stuff like that, but is there a proof of concept? Well, if you want a real good packaged proof of concept, you will have tame, and then people cannot use this excuse, we don't know if it's going to work in humans.
Right, absolutely. tame is obviously something that A4LI would like to see funded, and the government should have a vested interest in pushing not just metformin, but any drug that targets multiple morbidities at once, right? So I want to just go back though to your super centenarian study. I just have some anecdotal kind of discussion here, but I have a 95-year-old grandfather and a 75-year-old grandfather, and my 75-year-old grandfather is not doing great, not doing awful, but he has his share of health stuff, right? Just like any 75-year-old. But then my 95-year-old grandfather has probably the same level, right? But at 95, it's much more impressive, right? Just because he's 95, right? And so he was able, it feels like my 95-year-old grandfather was able to kind of, I don't know what it was. Maybe it's just the genetics. Maybe it's just his lifestyle. Probably a little bit of both, right? But he was able to kind of hit that outer curve and kind of delay the onset of the diseases, right, of old age. I don't know how he did it, but we'll see. We'll see if my grandpa Arthur might make it into that study in a little bit in a few years there, Nir. I might have another participant.
Well, the study. So a few things. First of all, the study is for 95 and older.
Perfect.
That will be our definition. We round to 100. So he could be in our study.
All right.
As far as the environment, one of the things we showed in our centenarians, we have 750 centenarians in my study, is that they didn't interact with the environment. I always tell about this 110-year-old, a woman who died when she was 110. When I met her when she was 100 years old in a New York apartment, she opened the door and she was smoking. Mm-hmm, mm-hmm. And I asked, nobody told you to stop smoking? And she said, well, all 4 doctors that told me to stop smoking, they died. but the point here is not that if you smoke for, 95 years, you live long life, but the fact that they've been protected against the environment, not only against the environment. I have 100 years old who have these genetics that's called ApoE4, that the textbook says you'll be demented at 70 and dead at 80, and they're 100 years old and not demented. So there are powerful genes that are protecting against the environment and allowing people to be healthier for much longer.
Yeah.
So what you're describing is exactly our experience. That the 95 are probably like the 75.
Right.
Absolutely.
No, absolutely. I hope I got my I'd be fine with either genes, but I hope I got the the 95-year-old's genes. Definitely.
Well, but if you need what we're doing is when we're discovering the genetics, we're developing drug to benefit those without the genes.
Right.
Okay,
Exactly.
those 100 years old that come to me and say, what? So what's for me? I tell them you're it. Okay, there's nothing for you. It's your friends that didn't make it, right?
Exactly. There's levels to this aging thing, right? But I think everybody would agree if we can all live to 100 in very good health, that's the future. Definitely, we would all be really happy with. So let me ask you this. So moving on real quick to the next question, but kind of related. What are the specific inventions in the relatively near future, let's say 5-10 year window that our audience should look out for? What are kind of the biomedical breakthroughs you're really excited about in the next couple of years? You don't need to go into too much specifics, but if you have general fields that you find interesting, or the pathways or hallmarks, you can be as vague as you'd like.
Certainly for lay people, I'd like to talk about 3 levels of intervention. One is I call it the Dorian Gray. Dorian Gray didn't get old, okay, but when he looked at the mirror, he saw his age. Okay, which is what happens to me on a Zoom. I see myself in the Zoom and I'm saying, oh, here's my real age, but I know I'm much younger, right? You can try it. It works very nice. And this Dorian Gray is, well, I'll tell you first the whole 3, and then I'll tell you what we have for each. The second scenario is the Wolverine, or maybe you can call it the Fountain of Youth. The idea is that you take a very old person, you put him in this pool, and when he gets out, he's young. Okay, this is very hard. I don't think it will ever happen, but there's something we can do about it. And the third scenario is Peter Pan, basically never get old. Okay, so the Dorian Gray is really what I described about metformin or rapamycin or some of those other things that are commonly known and some people are taking, okay, that they target the biology of aging, they delay aging, they don't stop it, they don't reverse it. Well, they reverse it in some ways. People who take them initially have benefits, but it's hard for you to know. If you stop aging, it's hard for you to know that, because that's what you do. That's where you are. You don't know how it would be without it, right? That's the problem with those remedies. The second scenarios of the Fountain of Youth, although I don't think we'll be able in the foreseeable future to go from old to young, they're for example, drug of class that are called senolytics, and they attack those senescent cells that accumulate in your body when you're very old. And not only they accumulate, they are harmful, so it makes sense to evacuate them. And when you do that in animals, they don't live longer, okay, but they get much healthier. Okay, so we can do even something about progressive aging, even if we cannot totally reverse it. Another thing we can do is regeneration. I mean, maybe we cannot do it at this time, but I think this is coming. If our liver is sick, well, we can regenerate the liver, or we can regenerate specific organs and help increase our health span that way. As for the Peter Pan, and I think the Peter Pan scenario, if I go, I would say 50 years from now, that's what will happen. Mm-hmm. We will be your age, Dylan, and go to a clinic, and they'll give us an injection of some Yamamoto factors and something else, and erase the aging that you accumulated so far and repeat it every few months or years, I don't know. And by doing that, you will reverse aging on the cellular level, and you might still grow old, but much slower. Okay, all those things are happening. We have to study them together. We have to study them in parallel because they also feed to each other.
Right.
The time course of each one is different.
Right.
I think Altos, this new venture, is really about the Peter Pan scenario, though I don't know that anybody can tell you officially their business plan. But the only problem with that is that it's what we call a moonshot. Okay. And moonshot for me is the moonshot example is complicated in the sense that, on one hand, it took us just several years to get to the moon. But on the other hand, so we got to the moon in the 1960s. And what did it do for us? The moon is still there. We're still here. So moonshots have to have a better purpose than the moonshot, in my mind.
Sure.
Now we're going again to the moon, but what will how did that help us? I'm not sure. So, but all those things are things that we can target, and we don't know where the breakdown will happen and where the cross help will happen. But all those are very exciting. They're in the labs, and they're our future.
So it sounds to me like you're way more optimistic on the Peter Pan than the Wolverine path, right? Just because you just find it more feasible. Why? Can you go a little more into depth on that? Because it seems to me like just from what I can tell, maybe stem cell rejuvenation, maybe tissue regeneration would fall into that Wolverine category, which seems to me closer to market than something like cellular reprogramming, right? So what's your kind of thoughts on that?
It's really much more complicated. So I'll give you an example. There's a faculty at Einstein who's thinking about brain regeneration. Okay. So there are a few issues here. First of all, let's say that you can regenerate the brain. What you don't want to lose, by the way, whenever you treat aging, you want a lot of things to be young. One thing you don't want to lose is your wisdom, right?
Right.
Wisdom is actually really, really important. But the wisdom also, with the wisdom is based also on your memories. So you have to first download your memories, your wisdom. You have to download every one of your neurons so that you can load it again in the new neurons, because otherwise you're a totally different person, right? And what's the purpose of that? If you wanted to be a different person, then have kids and die, right? I mean, I don't know why you have to become yourself a different person, but that's a philosophical, there are believers in that. But this is just the baseline, to think about the baseline concept. But even if you want to regenerate your brain, you have to do it, or parts of your brain, you have to do it in layers. Because each layer has to be a supportive for the next layer. You cannot do it together. And for now, it means that you have to have a surgery every time, an open brain surgery, in order to lay down the layers.
Right.
The FDA is not going to approve this approach even for a study, right? So I think the obstacles now are much greater than what will become just an injection. Okay. Sure. So this is just an example. It is some of the things that sound so simple are really much more complicated if you actually want to get permission to do that.
Right. Okay. Well, that makes sense. Well, take the brain part out of it, right? Like, it feels like we might be closer to like rejuvenating a kidney through like 3D printing.
Right.
I think definitely the metformin, rapamycin, I mean, those are pathways that are already available, right? The Dorian Gray method is already kind of here. But part of the A4LI mission is to unlock the government's kind of war chest to fund all three pathways, right? I think all three are worth looking at,
Exactly.
Yeah.
So I want also to give you an example because first of all, we have those hallmarks of aging. They're not done. They're not prioritized. We haven't discovered everything we have to do about aging. And although we have some treatments, we don't know where the next are coming from. I'll just give you an example. And you might have heard about it, hyperbaric oxygen. Hyperbaric oxygen was really invented to treat divers' diseases. If they got out from depth too fast, they had bubbles in their blood because of the different pressure, and it gave them strokes and other things, right? So you put them under pressure again with oxygen, and you get the bubble smaller. Anyhow, there's a whole procedure for that. But then it became treatment. For example, if you have an anaerobic infection, if you have germs that are doing great without oxygen, you actually want to give them oxygen because that kills them.
Right.
So people with wounds and with deep wounds and diabetics, and there's a whole other slew of indication that came out of it. And then those guys in Israel came and showed very compelling studies that showed that if you take elderly that have a little bit cognitive decline and you give them a treatment with hyperbaric oxygen, you improve a lot of things, both biologically and subjectively. Now, subjectively is the problem, right? Because you always have placebo effect. If you take a group of elderly people, put them in this submarine, and they meet every day, and then they go for lunch, and they paid a lot of money, they're going to feel better, no matter what. And by the way, the mood can also affect the biology, okay? So it's complicated. You always have to do it placebo. But the reason I believe that, so not only that, when I first heard that, I said, hey, we're all obsessed with antioxidants. Now, you're going to give a lot of oxygen under pressure. This must be so harmful. But now I know better, and I'll tell you the two things that I know is as simply as I can say. First of all, our blood supply is dramatically decreased with aging by almost 40%, which means that a lot of the cells that we have are not exposed to oxygen. So if all of a sudden you give them treatment for a few weeks where they get back oxygen for a few hours, it can recover them, and it can help sustain and improve tissue. Okay, so that's one point. The second point is actually from a biology of aging perspective, what's good is to be hypoxic, to be without oxygen. But of course, because if you're without oxygen, you do have response that is pretty much consistent with an anti-aging response. We called it a hormetic response. When you do the oxygen chamber and you go to high oxygen, which is the opposite of hypoxemia, but then you go back to baseline. When you go to baseline, you get the response that you get with hypoxemia. So in order to tie all these things together, I actually purchased for our core at Einstein a hyperbaric chamber for animals so that we can actually look at the biology, because the biology you have to look at in sophisticated ways that we cannot do exactly in humans, and solve the placebo problem and have tissues so you can measure things that are consistent with their effects on aging.
Right. That's fascinating. So going back to the hallmarks of aging, lack of oxygen, right? That's not one of the hallmarks, right? So like where would that fit into the 9 or the 7, 9, whatever they are right now? Are you saying like there's like a new, hallmark that kind of needs to be created, or are you saying that kind of fits into the existing framework today?
So, okay, to be a hallmark of aging, what you have to show, in my mind, is that something goes wrong with aging. And when you fix it, you get in animals improvement in their health span and lifespan.
Mhm.
Okay. This is my criteria. I don't believe that all the hallmarks stand exactly this criteria, but I agree on the hallmarks that we have.
Mhm.
But I think there are much more hallmarks, and more important, there's interaction with the hallmarks. So when I said you target 1 out of 9 of the hallmarks that we quote all the time, and you get improvement in health span and lifespan, you get also improvement on the other hallmarks. You don't have to treat all the hallmarks to get an effect. So I think the hyperbaric oxygen is doing that in multi-levels like that. It does it on the metabolic observation that blood doesn't get to cells. Okay, so it's in the metabolic hallmark, but it also going to change a lot of the others just because of the rejuvenation that you get.
Mm-hmm.
But is okay, so the hallmarks, okay, the hallmarks don't include metformin, rapamycin, hyperbaric. Those are the treatment, right?
Right.
It's what they target, and it can target.
What is hyperbaric? What is the hyperbaric chamber? Or the oxidation chamber? What does that target? What out of those hallmarks that we know of right now?
Well, probably a lot of it is metabolism, really in relationship to blood supply.
Gotcha. Okay, cool. I was just curious. That's fascinating. So, that's an approved therapy for other diseases at the moment in the U.S., right? Hyperbaric chambers.
Actually, there are other diseases, and also there are evidence on post-traumatic stress, long COVID. There's a whole slew of things that have been improved by hyperbaric oxygen.
Improved and approved by the FDA for treatment?
No, not approved. No.
Anything been approved? No.
It's not approved.
Not approved for anything. Gotcha.
Right. But I have to tell you, there's a lot of there's companies that their hyperbaric chamber sets in almost every city in the United States here. Okay.
Mm-hmm.
And you can go privately to this. Not only that, there's a chamber for 2. I talked with some investor, and I talked with them about the hyperbaric, and I said, "Oh, I just bought a hyperbaric chamber." I said, "What in your apartment?" Yeah, it's a chamber for 2. So there's a lot of business around that, but there's also a lot of biology. Mm-hmm. But my point in all that, I gave a more thorough story, but the point is, I don't know where is the next big thing coming. Like, I had no idea that this hyperbaric is going to be something that I believe in, right?
Gotcha. That's fascinating. I think, one of the things we want to do with the government and, just the FDA in general is encourage them to have all biotech or as many biotechs as possible check their drugs for aging, right? Create some sort of tax incentive or something like that to get companies to do that. Because in the case of, the hyperbaric oxygen chamber and the, and metformin, right? None of these things were created with aging in mind, but then, you apply it with an aging lens and it clearly makes a major difference. So rapamycin as well, right? All the things that are actually readily available today are things that were intended for something else, right? So I think more kind of companies and drugs need to be encouraged to put this aging hat on and take a look if their drugs do anything on that front. So yeah, I think I'm with you. Yeah, we don't know what the next big invention is, right? It's yet to be known. We'll know when we know, right? So we have a few minutes left here, so I want to ask you, our final question here, and what I like to end our discussions on is I like our guests to give their forecast of the future. How do you feel about the future of humanity? I'm of the mindset that we should be optimistic and hopeful for what's to come. I would like if you could give our listeners some hope. What should we look out for? What should we be looking forward to in the future?
Yeah. So as you're asking the question, I used to say for those questions, I used to say 5 to 10 years, and I was wrong. Okay, it was always longer, but should I just continue and say 5 to 10 years, or maybe I could tell you it will all be solved by February. And as long as I don't say the year, I'll be right. It's really hard. I find that the predictions are becoming even wilder than with time. But I would say the following. Our life expectancy as a species is 115 years. That's a statistical answer, right?
Huh.
There's somebody who lived to be 122, maybe more than one person lived to be 122, but statistically, it's 115 years. And yet life expectancy now in the United States is dropping, and it's at 76, okay? And I think our standing in the world went from 36 to 45 or something like that. Yep. Really terrible statistics. But in any case, in the United States, you have, 35, 40 years that you can still realize as a species. And by no way I'm saying that you cannot cross the 115 years in the future, okay? But I'm saying just take us for what we can accomplish with the body we have. We should do much better, okay? We have 35 years to realize. I certainly have an example for the 100 years old, so those are 20 years to realize. And I think we should be there within mine and your generation, and then I think the future will be accelerated. So yes, I'm optimistic. I think that aging can be targeted right now. It's more of an administrative nightmare that we have, but right. We can do much better than what we're doing, and it's going to be accelerated.
Right.
And my emphasis is always on the health span. For me, the lifespan is a side effect. If you'll be healthier, you'll also live longer. Yep. But it has to be the lifespan. It has to be the quality of life. And we have to keep it this way. We don't have to exchange just lifespan without health span.
Right.
So yes, I believe that the future is right now, and it will accelerate, and that certainly both of us will live longer than our parents and in better health.
Right. Agreed with you. And, I think everybody wants the health span, right? Health span is becoming such a popular word these days. Nobody wants people to be,
By the way, I should claim it. Health span, which I spelled, by the way, one word, is really my invention. Okay. And the reason is, when I started doing aging research, everybody heard aging, said, thank you very much, we don't want to hear much. But then I said, just a minute, but I have centenarian, so I have longevity. Mm-hmm. So I started talking about longevity, and I realized that I didn't have more audience, because everybody assumes when I say longevity that we're going to live longer sick. Okay. And then I moved totally, and I started talking about health span, and I made it one word that is a problem because it cannot be translated to other languages in one word. But absolutely, health span was my way of dealing with my frustration when aging. Longevity didn't make it on their own. But it's really a better cause, and it captures everything.
Sure. Yeah. Well, that's the ultimate goal, right? I think of all medicine, right, is to increase health span, not even just specifically aging medicine, right? I had you on our discussion with Newt Gingrich and Steve Israel last year. I think I started off this way. All medicine is health spanny in nature, right? So yeah, no, I'm with you. It is frustrating that aging is like a taboo kind of thing, but hopefully with our continued advocacy near we can change people's minds over time, and more people can actually, we don't have to create words out of frustration to kind of convey what we're feeling, hopefully in the future. But it would be morally and economically unacceptable to make people live longer in an unhealthy state, right? So we're pushing for the same thing here, right? So Nir, we're out of time here. I want to say thank you so much for joining. We plan to have you back on soon, Nir, to give us updates on TAME, FAST, and the super centenarian trials. And I'm sure you will have more things on your plate by the next time I see you. So let's plan again, Nir, to have you on. If you have anything you'd like to say to our audience before you leave.
Thank you, and go ahead and change the world for us, Dylan. Thank you for your efforts.
Us together, Nir, hand in hand. All right, cool. Thank you very much to everybody for listening to A4LI's installation. We will be back in 2 weeks with our next podcast installation. Thank you so much.
Thank you again to Dr. Barzilai for coming on to our podcast, and thank you for all of our listeners for tuning in. If you have anyone you would like to see make an appearance on our podcast, you can send suggestions to us at info@a4li.org. We will be back in 2 weeks with our next podcast installation. As always, let's live long and prosper.